All right, in this video, we're going to talk about the real number system. So it's really common for people to kind of forget what the different categories are and what kind of numbers we mean when we say those words. All right, so in Algebra 1, you really only talk about real numbers. Now later when you get into Algebra 2, you get into complex numbers and imaginary numbers. But for now, this is just going to be about real numbers. So real numbers are all of the kinds of, for lack of a better way to say it, real numbers you can think of. Fractions, decimals, square roots, whole numbers, all of those kinds of things are real. So there's really two main categories of real numbers. There are rational numbers and there are also irrational numbers. And I'll give you some examples of each, okay? So the main thing to notice in this word rational is ratio, okay? So ratio is just another way of saying it's a fraction, okay? So a rational number is a number that can be written as a fraction. So that would obviously include any kind of fractions like 1/3 or -5/7 or any other kind of fraction you can think of, 2 and 1/1000. But remember what we talked about, well, never mind. But you can write any whole number as a fraction by just putting it over 1. So like if I had the number 4, I could write that as 4 over 1, and that would be a fraction or a ratio, a comparison of one number to another number. So any of your whole numbers, whether they are positive or negative, like 4 or -11 or 2,341, those are all rational numbers. Also, any decimal that is ending or terminating. So that would be like 0.6, okay, or 6/10. Or if I had 0.75 or 75 hundredths, if you say it that way. Those are all numbers that could be written as fractions, okay? It also includes any decimals that are repeating. So like 0.3 repeating, it's the same thing as 1/3. So any terminating or non-terminating decimals, those are all rational numbers. And so at this point, it probably sounds like, well, everything's rational then, but it's not. So irrational is any number that cannot be written as a ratio, cannot be written as a fraction. It's not a whole number. It's not a repeating decimal or a terminating decimal. So we're talking non-terminating, non-repeating decimals. That would be things like pi. Pi is 3.141529 ... It keeps going forever and not in any kind of repeating pattern that we have found. You may not have seen this yet, but there is E. It is another irrational number that you learn about in Algebra 2. And it is that same kind of thing, 2.71828 ... It keeps going. So also, any kinds of square roots that are not square roots of perfect numbers. For example, if I said the square root of 9, well, the square root of 9 is really just 3. So the square root of 9 would be rational. But if it's not a perfect square number under the radical, like the square root of 2, that would be irrational. It's 1.414 ... It keeps going. Okay, so square root of 3. Square root of 4 would be rational because that would just be 2. Okay, square root of 5, and so on. Those are the kinds of numbers that are irrational. So a lot of times we deal with rational numbers, okay? But there are smaller categories of rational numbers. So a smaller subcategory of rational numbers would be integers. Right? So integers would be numbers that are whole numbers and their opposites. So that would be things like 0, 1, 2, 3, and so on, continuing forever in that direction, but also their opposites, so I'm also including the negatives, -1, -2, -3, and ... in that direction. So those are integers. A smaller subcategory of integers would be whole numbers. So whole numbers means we're just going to not use any of the negatives. So if I take out all the negatives in that previous list that I had, then that means whole numbers are just numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, continuing in that direction. Now, there's one smaller category than that, and those are natural numbers. Natural numbers are also referred to as counting numbers. So if they're counting numbers, think about where you start when you start counting. We start with 1. So the only difference between the whole numbers and the natural numbers is that the natural numbers do not include 0. Okay? So this is your categories of real numbers. There's rational and irrational. And then within rational numbers, there are numbers that are called integers or whole numbers or natural numbers. So let's say I give you an example. Okay, so we're going to look at the number 7.1. So we're going to decide what kind of number is this. Okay, and think of all of the categories that would correctly describe this number. So 7.1, well, first of all, it's a real number. Also, I could write that as a fraction. That could be 7 1/10. So that is also a rational number. But that's all the things I can call it, because once I look at integers, there aren't any decimals anymore. So I could only say that that number is a real number and a rational number. Okay, so it falls into both of those categories. All right, let's try one more. Let's say I have the number -5. Okay, so -5 is obviously a rational number. I could write that as a ratio. Also, it's real. And if I keep looking at my list, it would be an integer because the whole numbers and their opposites are all on that list. But that would be as far as I can go, because once we get to whole numbers, we don't include any of the negatives. Okay, so those are some examples of how you can tell what type of number something is.